welcome to the first official meetup of the Sacramento AI Meetup. Really excited. I did sort of a test run. Who was here for last month, or 2 months ago? Billy, you were? Yeah, we did a test run. This is a little bit of background to what Craig's going to be talking about today. But I was getting ready to go to Austria to speak at a conference in front of 1,500 people talking about AI. And I didn't know anything about AI at all, but I've been asked to do this because I've written programming books. And I went out there and did this talk, and I was on right before John Romero from id Software. And I was talking about AI, and it went pretty well, but my whole talk was about sort of a gloom and doom situation of AI leading directly to the end of the world. And it was funny, but it was also very pessimistic. And so Craig proposed that he do a talk at the meetup giving a more optimistic vision of the future of artificial intelligence. And so this is Craig's answer with a lot more technical details because he knows a lot more about AI than I do. And so this is Craig Mary. If you're on the SlackTech Slack group, he is the guy who knows a lot about AI and is talking about AI all the time. He runs a company that's working with AI, and I've seen his presentation. I think this is going to be really good. And forward to this end, Craig, take it away.
All right. Thank you, Chris. Good evening. How you guys doing? Good? All right. Welcome to the reality and potential of artificial intelligence. What this talk is and is not. This is a brief overview of artificial intelligence, machine learning, and neural networks. And mostly the libraries I've dealt with are based in TensorFlow for machine learning. I'll also go over a little bit over use cases in TensorFlow and sort of what the private industry is doing in machine learning and artificial intelligence. Again, this is not a comprehensive look. This is a big field. All right. Outline of talk. I'm going to introduce myself, a few definitions to work with, and then we'll go through a brief history of AI, and then a machine learning introduction, and some use cases in both like personal applications and corporate applications. Designing for AI. This is probably one of the most important key pieces for AI adoption, so it's a good section. Positive side of AI. So this talk was kind of in response to Chris Minnick's presentation. I'm going to kind of go over that a little bit. And then last but not least, Q&A. And if you guys have a question, like during the talk, and you can't memorize it, you don't have a notepad, whatever, just tweet at me, and then after the talk is over, I'll take a look at the questions on Twitter. This is also a way for me to answer your questions before Chris Minnick takes the questions, because I am mostly deaf. What that means is I won't be able to hear you. You can talk, do all that stuff fine, but I won't be able to hear your questions, okay? So that's a two-part Q&A. Take the tweets, and then allow Chris to listen to the questions, and I'll try to answer them. Okay. Awesome. All right, so who am I? My name's Craig Mary. I'm 31. I have a bachelor's in political science. Didn't know if I want to be a lawyer or a politician. So, anyways, 10 years later, today I'm running Beacon Safety Co. And basically we're applying machine learning to a smart bike light and also to a social network built on top of MapMio. And essentially what MapMio does is it allows users to declare their transportation type and make roads a little bit safer. It's complicated, but it's there. My current projects right now, I'm building Cavalcade, and I'm working on a few bots and translators to help me and some of the people I know that are deaf. And then in the meantime, I'm fundraising for a shuttle service for AV vehicles, basically based on a bus. and made in France. It's pretty sweet. All right, so why am I here? Chris had a request for some feedback about an AI presentation he was giving in Germany, right, in Berlin.
Vienna, in Austria.
Yeah, and I was like, oh, awesome. Let's open it up, and I love talking about this stuff, right? And it was great. I mean, it was awesome. It was good for the audience. It's good for the perspective. And I was like, well, I kind of wish we talked more about the potential of it, and how we can use it now. As for this meetup, I hope like down the road you can have more workshops and talks and different people coming up to give their take on artificial intelligence. All right, so what is AI? Back in 1955, a group of university researchers decided, hey, let's submit a proposal to make an AI machine in 2 months. So this definition, the basis of it is that the machine can use abstractions and concepts much like a human can. And while the research 10 years later was important, a lot of the funding dropped out. All right, so there's 3 different kinds of AI. There's weak, strong, and general artificial intelligence. Weak means narrow or really specific tasks. It's not that smart, but it's something to recognize. Strong AI. There's a perspective that instead of weak AI being a simulation of the mind or that narrow task, it's actually a model of the mind itself. So how it actually interprets and does multiple tasks at once. In general artificial intelligence, that is the real, fantasy land, humanoid robot that you can't distinguish at all. Okay? And that's probably the ultimate goal, or that's sort of the end of the spectrum for AI. So one of the professors that worked on that, Summer 56 project, he wrote a series of philosophical papers on artificial intelligence. And he basically said that AI really comes from a society of individuals and not just one person. And if you apply that to a strong AI, that's a totally different paradigm than what a weak or strong AI is. And as for me, myself, as an American, I strive for, life, liberty, and pursuit of happiness. Why do I work 40 hours a week as opposed to 30? It's just this balance. Just something to keep in mind throughout this time. All right. So I kind of went over the different kinds of AI. I'm going to outline the goals of AI. The most basic goals are reasoning, problem solving, how do you gain knowledge, how does someone plan for something, and of course that kind of leads to learning. How does someone take a concept and apply it to something? And of course, we're always fascinated with how a robot could imitate the 5 basic senses. Can you see, hear, touch, smell, and taste, just like a human can. Other senses could be internal, or a sense of balance, things like that. And of course, another field for that goal is robotics. That's extremely important for trying to get to that general artificial intelligence point. How does a human body actually work in the skeletal system? Another goal is social. Without any social intelligence, a robot's just going to run amok. It's going to piss off a lot of people. One of the things that's innate in humans that I think really strives towards general artificial intelligence is creativity. how can you form those abstracts from a robot and oh wow, it's really original. And of course, the final goal being artificial general intelligence, the complete humanoid that you can't just distinguish from a normal human. All right, so there's a few approaches in trying to get to that last goal. There's brain simulation or recreating the brain. I mean, literally, hey, let's just make a brain and see what happens. Symbolic. And symbolic, that means written language or numbers. Right? So formal reasoning goes into that. Non-symbolic, so essentially that's the relationship between things. And of course, within that list, we'll find machine learning, statistics. More recent evolutionary algorithms, pretty new, starting to bubble up, and it's pretty fascinating results. Or you can mix and match, and that's always interesting, but much harder to verify and validate and model. Philosophy. What is intelligence? I mean, that's an age-old question. You have an IQ of 200. Great. What does that mean? Even if a non-organic creature had probably the same capabilities like a human, could it have consciousness and emotions? Could it feel? Suppose we could create robots with intelligence comparable to ours. I mean, should we? Is it dangerous? Is it immoral? What kind of rights and privileges would robots have? And here's a great example from the movie Ex Machina.
Good.
I can't hear. That's all.
This is bad.
First a traffic intersection, and then the show.
I'd like us to go on a date.
Yep. Yep. It'd be fun.
Are you attracted to me?
What?
Are you attracted to me? You give me indications that you are.
I do.
Yes.
How?
Microexpressions.
Microexpression.
The way your eyes fix on my eyes and lips. The way you hold my gaze. Don't. Do you think about me when we are together? Sometimes at night. I'm wondering if you're watching me on the camera.
Awesome. Okay. Cool.
Like closer.
All right. All right. So I think that's a great representation of general artificial intelligence. That's basically the goal. All right. So a brief history. One of the things that I admired growing up was like Greek mythology. Right? Hercules being super strong and godlike powers. And of course, there's other heroes, if you will, given these superpowers. A couple thousand years ago, in early philosophy, we started with formal reasoning. Just being able to use symbolic mathematics and argumentative reasoning. Of course, algebra came along with algorithms, which were attributed to Mr. Algorithm. And then the next step was logical machines. Could you put a machine responsible for the inputs and outputs? And that was advanced to what we have, what I call modern era, which is basically 1930s on, with the Turing machine and the Turing theorem, which states that you could only process 2 states, 1 and zeros. And these algorithms and Turing machines were critical in the Enigma efforts of World War II, breaking those codes from other countries and so on and so forth. So the Turing test. The Turing test basically says, can the machine imitate a human, and can the judge tell? It's the most basic test there is. It's not universally accepted, of course, but it's something to stand by. And this is a little Dilbert comic that actually came out the other day. I was like, oh yeah, okay. Can you pass the Turing test? No. Can you pass the robot test? What's the robot test? You vote, even though you don't understand issues. I might do that. You just fail the robot test. And the joke is, a robot would understand the issues every time. Another clip from Ex Machina, and he's introduced
you know what the Turing test is?
Yeah, I know what the Turing test is. It's when a human interacts with a computer, and if the human doesn't know they're interacting with a computer, the test is passed.
And what does it pass to us?
That the computer has artificial intelligence. Are you building an AI?
I've already built them. And over the next few days, you're going to be the human component in the Turing test.
Oh.
And then later on in the movie,
You feel stupid, but you really shouldn't. Because proving an AI is exactly as problematic as you said.
What was the real test?
You. Ava was a rat in a maze, and I gave her one way out. To escape, she'd have to use self-awareness, imagination, manipulation, sexuality, empathy, and she did. Now, if that isn't true AI, what the fuck is?
So my only function was to be someone she could use to escape.
Yeah.
And you didn't select me because I'm good at coding.
No. Well, no. I mean, you're okay. You're even pretty good,
You
but
selected me based on my search engine inputs.
they showed a good kid
With no family,
with a moral compass.
no girlfriend. Did you?
and so in the modern era, so after the first artificial neurons were hypothesized, so neurons and neural networks, neural networks, when they were first hypothesized, there was no way to solve the and/or problem. There were no hidden layers yet. That was in the 80s. So after the research funding of the 50s and 60s, early 70s, they were dropped off because the promise of AI really wasn't there yet. The mathematics and computation power stalled. It wasn't enough. So there weren't enough, to go through with more development. But then in the 1980s, new hypotheses came up and expert systems were introduced. How could a subject matter expert help out, in a financial transaction, so on. And there was more advances in home automation or home machines. And in 1987, the Lisp machine crashed. I'm not sure if Chris, you were familiar with that topic, but that would be a fascinating case study there. And that became the second AI winter. Research dollars dried up again, and we had to wait until the late 90s, 2000s for big data. The computational powers, in accordance to Moore's law, increased. Data mining became more widespread and cheaper to utilize. And use cases were mostly towards logistical software and medical diagnostics. And of course, during this era, there was a lot more curiosity towards inferring stats and coming up with different ways to get better results. 1997, Deep Blue, IBM, defeated the chess champion. I think it's Kaspersky. And I remember being a kid, that was a big thing. And I was like, okay, a computer beat a chess champion, big deal, But, all right. So 2006, the MNIST data set was published, and error rate was measured. So this data set is considered to be the most basic data set in machine learning. And this data set is handwritten digit recognition. 2015. Further advancements in computational power and statistical techniques, especially in machine learning, allows for image recognition to be better than a human. So a human can recognize an image or the object in the image 95% of the time. With Google, they managed to squeeze out 96%. And I was like, all right, great, what's next? 2016, AlphaGo beats the Go champion 4 out of 5 games. That was a pretty big deal. I don't understand Go at all, but in terms of complexity in games, that's a pretty impressive accomplishment. In terms of theoretical developments, the subject matter expert test was developed, and it was a variation of the Turing test. Instead of a pure, are you a computer or robot or human? And those tests would be based on chemistry, geology, and other things. And one of the more important developments that I found was that you can classify how well the computer does, based on a given test. And for me, that's important in car automation. I'll bring it up later. Machine learning is a big field. I cut out a lot of my slides from a previous series, and hopefully it's concise enough to kind of show how machine learning has impacted AI and kind of grow. All right. What is machine learning? It's basically mathematics applied to computer science, create models that can do two things: make predictions about the future and discover patterns in data that we may not have normally discovered. And that's just a basic system of how you would go about testing your hypothesis. It's very important to distinguish the process of constructing a model and using a model. When you're using a model, all you're doing is you're inputting the data and then processing it through the model to get the result. And then constructing a model, you have to choose the algorithm that you want to solve the problem with and feed it with the data to get your model. In machine learning, another important aspect of it is you don't want to do it procedurally, A, B, C, and so on. You want to have your programming to be flexible and not explicit. And of course, the big advantage with machine learning is you can introduce new data points or big data points. So algorithms. So functions are a part of the machine learning prediction step, and those functions are in algorithms, which is a predefined set of steps that takes input from a bunch of data and then transforms it into a mathematical operation. So it's much like cooking in a recipe. If you do this, then that. So that's the algorithm. And the model in machine learning is it's a representation of the real world. The machine learning project approach is very scientific in that it's repeatable and verifiable. And this is kind of an outline of how you would approach a machine learning project. But before you get into a project, you want to frame the problem. Is it classification, regression, or something else? Classification is just you're trying to group things into that class. Here's a dog. What kind of dog is it? And so on. With regression, usually with regression, you're trying to find a single variable to predict a certain outcome. And then you want to pick your algorithm type from that. Supervised, unsupervised. Is it reinforcement learning? Or is it a mixture of all three or two? That's called hybrid. And then you need to determine what kind of learning will occur. During training, are you going to do small batches of the training set? How much of a bias or skew are you going to have for training images, testing images? And then whether or not you want your system to take in new data points while it's live, in production. So I'm going to break it down into supervised and unsupervised reinforcement learning and hybrid. Supervised, without spam filters, we would still be battling spam, every day, and that's a waste of time. With supervised learning, basically you're trying to identify, which emails are spam, and not spam. After you have, a couple 100,000 emails, you can probably get a good spam filter to run with. Unsupervised. Think of it literally as a bunch of kids in a room and you're trying to cluster them, somehow make sense of them. And this is where machine learning really lives. Hybrids. So this is a really complicated graph. I don't want you to study it too much. It's just trying to show how there could be different layers during training to create that model for accuracy. Sometimes I wish I didn't cut some of those slides.
No,
It's all right. All right, so reinforcement learning. This is probably where most of true AI will live. It's where the agent or the robot will learn the rewards or consequences for any action that they take. So what is deep learning? Deep learning is more of another word or synonym for unsupervised machine learning. Deep learning is really just a nice PR marketing term. It's got a lot of different connotations to it, in my opinion. But it really relates to neural networks or artificial neural networks. Why I'm excited about machine learning. To train a model and to execute a model is extremely cheap. Right? To run a model, you only need a Raspberry Pi 3. You can do an image recognition program for 2 hours. Depends on how your skill level is. To train a model, let's say you use a Raspberry Pi 3 to train a model, I'll probably take you 8-10 hours. It's a little bit longer. But with a typical CPU like this, i5, you can probably compress that to 3. It's fast. And I like to work with Python and not C, so it's really easy and cheap. It's also popular for researcher and production. I've seen in a few production products, we'll go through those. You can train on multiple servers. Millions of data lines or images or whatever. You can go that far if you want to. It has great tools like graph visualization. You can zoom in onto where your error rates are and kind of dissect it. So a pure example of machine learning, just it's more of a joke than it is a good example. So when a user takes a photo, the app should check whether they're in a national park. Sure, easy GIS lookup, give me VRs. And check whether the photo is of a bird. Only research team in 5 years. So this comic was published in 2012. Today this will take you 10 minutes. If you want to retrain that network, it'll probably take you an hour. It's pretty incredible. All right, so in this data set, I'm going to use this as a case study for machine learning, how you go through the process. All right, so what's the problem? You're trying to determine, that's an 8 or a 4. Real simple. You get the data. This was 1996. Some guy said, all right, here's, I think, 80,000 images. There's the data set. And so then you start the process of analyzing the data and kind of seeing what it looks like, feed it through your algorithm, and then let's see what the visualizations look like. This is a quick visualization. I forget which algorithm they use for this one, but you can kind of see where the positive weights are and the negative weights are, and you can kind of see the outline of the number itself. This is basically what the computer sees. This is what the model looks like after you get some of those values. It goes through a series of steps, and then you have your model. What's great today is an online platform called Kaggle, K-A-G-G-L-E. It's a platform where you can share results with people from all over the world. In this particular screenshot, it shows a Python notebook that shows all the steps and then presents its findings. I just chose the top one and 98.45. That's a pretty good model. So 98% of the time, the computer's going to get any handwritten image correct. Use cases, the fun part, for modeling to real life projects. And the point I really want to stress here is that you can use machine learning in your projects if you choose to. It's easy. You don't even have to go that far with linear regression to get what might be considered machine learning. So one of the fun use cases has been the ability to match together an original image, or in this case an online video, and then combine it with artistic styles, so like Van Gogh or other famous artists, and you can make a blend, or you can make a pure Van Gogh. So that particular video, Google researchers said, oh, I was just taking an online video and then mixing that with some of those filters. Yeah, that's fine. All right. So case number 3, the kind of things I've been working on, object recognition. What's in the image? So about 2015, computer vision in the simplest form is solved. Just basic image object recognition, it can outperform what a human can do. So that panda right there, a human, 95% of the time. Computer, around 98. This is a fun project researcher did. He built a $100 robot that goes around its house and identifies objects. So in this particular video, in the garage, he goes, oh, this is a red guitar. And you can do this yourself, in your garage if you're so inclined. Here's another research video. This is a train passing an office. San Francisco, and they want to determine if it's a cow train or a BART train. PiBot racing. You take a Raspberry Pi 3, slap on some sensors, and you're coding at home, and hopefully it goes around the track really fast. This was the first iteration from like a year and a half ago, so it's not real great, but you kind of get the idea where, okay, if I can do this, maybe I can scale up. And that's starting to happen. Yeah, so again, the performance of these particular machines is terrible, right? You don't want that on the road.
They already have that.
Different measurements. OpenAI Gym and Universe. This is a clip from Grand Theft Auto 5. And basically it's a computer driving the car throughout the game. How well does it do that? I don't know if they took off Grand Theft Auto 5, but theoretically, if you go home, go to OpenAI, get their code base and play around with it, and let it do its thing. Commercial use cases. So remember the little super strength thing? Yeah. Exoskeletons. So in the military, this is really valuable because they have packs like 180 pounds. And, that's a pretty tiring real quick. Other uses would be like in medical use, like someone disabled and can't walk and want to walk. That's possible now too. Industrial, lifting heavy boxes or twisting and turning or heavy tools. Chatbox or Shadowbox. They've been around since like the 60s. Amazing. As part of that research initiative. And quite simply, it was rudimentive or primitive. And I think since then we've kind of evolved a little bit with the chat box, and I don't think it'll ever be Turing complete because it's a computer. You're still talking to your screen. Modern chat box. So there's been advances, of course, in APIs and cloud computing. I don't know off the top of my head right now, what you would use for automated chat boxes. I'm sure they're there. Yeah. Anyways, it's valuable because the customer service aspect of it, of maintaining a chat box versus hiring a team of 10 people to do those same questions, might be worth it. This is Viv, which was later bought out by Samsung and is now rebranded as Bixby. Supposedly it's supposed to be out there. And this is a short example of how complex the queries have become for these voice assistants. Siri's a lot more narrow or weak AI. It really, all right, that's novel, it's great. But with Bixby, that's a lot more complicated. And I want to get my hands on it and try it out myself. Another interesting angle from all of the AI revolution is, what departments could we actually replace, in a corporate team? So let's take a financial team, Bridgewater, the world's largest hedge fund, like $250 billion in assets. And the founder's like, hey, I have this vision where, I want the company to run exactly how I want it to, even though I'm not there, I'm on vacation, whatever. And so certain units start getting churned out, like HR, finance, some of the basic decision-making things. And his idea was, well, all right, 3/4 of the workforce can be replaced within 5 years. I don't know how that's going. There's debates around that. I'm sure, Chris has some opinions on that.
Yeah.
But that's what's happening. Writing news content. obviously this was was starting to be a big player in our election cycle, especially last fall. It will continue to get better, and I don't know if or how Washington Post is going to be handling that sort of distinction between a human and a robot and so on, but that's happening. Legal. So some things in the legal AI sense. You can have a bot argue your ticket for you. Just tap a few buttons, state your reason, it handles everything for you, and you get a result back. Pretty nice. So other use cases for legal, I think right now there's bots that do legal documents. They look at the evidence, they look at what happened in the past, or they try to make new arguments to kind of get the best possible outcome. Google's auto draw. So when I first saw this on Product Hunt, I was like, this is so simple, it's amazing. You just do a drawing, and it will give you a little touch bar of icons of what it thinks it is. I mean, of course, it could be smarter or more intuitive. If there wasn't an icon, just transform it immediately. But they added that, so pretty neat. So in computer vision, some of the things we can do now, just a regular Raspberry Pi, you can detect the human emotion just by presenting points to the face, and then on the right side, how often a person blinks, or the EAR metric, which is a metric designed to detect how sleepy you are. So if you're behind the wheel of a car and you have the system going, it will let you know that you're drowsy, you need to pull over or something. Google's Translate. This is awesome. So basically what it does is it reads a foreign language and puts it back to the language you want. So if you're traveling, in Spain or something, want to know what that street sign says, there you go, Google Translate. Pretty nifty. One of the things I'm most excited about is Apple finally pushing out a dev release of augmented reality. And today they announced that, hey, we're going to partner with IKEA and put this app out in the fall. Basically, what you do is take the room or interior or whatever, the iPad, place whatever object you want from IKEA. You usually see it, it just looks right. So I'm going to save a lot of effort and time from actually going to that first step. Netflix. So I use Netflix, and sometimes I wonder, how do we get these movie posters? Humans doing all the clipping, cropping, and stuff. Nope. It's all an AI bot. Based on your personal preferences and viewing history, what you actually clicked. So that's all of a bot. Amazon Go. This particular video was produced by a company in Sacramento. I get the name of it, but as soon as I saw it, I was like, wow, that's awesome. That's a feature. They just bought out Whole Foods. And I knew right away, it was like, all right, it's computer vision, it's a little bit of tracking, but that's great. There's no cashier.
Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake,
Anyways.
just put it.
All right, so design for AI. This could be a critical component if we want to get into the autonomous vehicle segment. So, number one, what problem are you trying to solve? Any investor, that's their number one question. What are you actually trying to solve? don't just build a product for the sake of it. Be specific and clear. And usually it's just a niche market. Design is context specific. Like, don't write out a gate, try to create a robot that actually has emotion. You know? So many things could go wrong and so much time wasted. Design actually enhances the human ability, and this is important for me. You know, for someone being deaf, is that I would want this to be a complex system to augment my ability. Some might call that augmented intelligence. It's kind of confusing, but it's all of it. A great example of that would be the exoskeletons for disabled. Good design works for everyone, every day. Imagine going home and installing a bunch of smart lights, and you only program it to your phone or your command or your voice or whatever. Your neighbors come home and you're like, how do lights work? So you want to make sure your design works for everyone within an environment continuously, day in, day out. Good tech and design is discreet. Probably one of the most amazing recent experiences for me personally was the August door lock. Right? Easy to use, and just the interaction you have with it to confirm that it's locked or unlocked. For me, I was like, wow, that was really nice. I don't care how much it costs, I want that. Good design is a platform that grows with needs and opportunities. So this just means that you have a product that can be updated easily and it can enhance the value to its customers. For me recently, that's just been places in the ecosystem. And, oh yeah, I use all these cable channels, so half the price. And right away, it's like, oh yeah, this is gonna be a lot better than Comcast, where they update their box like once every 5 years or something. Right? It's terrible. Number 7, good design brings about products and services that build long-term relationships. So basically what that means is you want to create a product that's just for the season or for a particular property that user may not be aware of. And I was going to add a clip of her where in the movie she just turns off and he like panics and freaks out. Right? That's probably not the behavior you want in this society. Good technology design learns and predicts human behavior. You want the AI to predict the human behavior in a way that serves the user and other users around you. And this will be really clear in a few minutes. Good design accelerates new ideas. This is pretty simple. Just think about the iPhone. Good design removes complexity from life. So this is probably the most important principle for any design project is, does it make my life easier? Am I going to recommend this to a friend? Case study. So in design, the AV market is just, so there's a lot of promise and hope and expectation and money. And to kind of understand where it's going, how it got there, it takes a little bit of a few weeks to dive in, but I'm going to try to do it real quick here. All right, so why should we do this? Number 1, safety. We can reduce traffic collisions, and some studies say up to 90%. There's more than 35,000 deaths in transportation in California each year. That's a lot of people that could be contributing to the economy, and so on. Labor costs. So obviously, yeah, you might have some job loss with big rigs and taxi drivers, but for a business that might be great. And for AV cars, the constraints of impaired driving go down. You can freely text or freely watch a movie while you're on your commute, or you can get business done while you're on your commute. some studies also say that, well, there might be higher speed limits, less traffic congestion, fewer traffic police. And of course, your vehicle insurance rates will go down, along with improved fuel efficiencies because the cars can be closer to each other. And some of the options that can be introduced is car sharing. You usually give your car out to another person, or order a car that's completely AV and comes to you. Why we shouldn't? There's a lot of reasons why we shouldn't, to be honest, and they're very good reasons, right? And in terms of design, you have to consider these things if you're going to have any sort of adoption. So, whether it's the system itself being incorrect or having some sort of failure, or the economy might be so deficient that you have to ban AVs for some reason. So what I find kind of amazing is that current cars that aren't AVs already have all these electrical systems in it, right? And different computers for different things. So it really just takes something that meta that can handle all that for you. All right, so the classification thing that I was talking about for AI earlier. So level 0 AV means that mostly a modern car with like safety warnings, about cyclists around you or whatever, right? All the way down to level 5 where completely autonomous and can do whatever it needs to do on the road. And in between, you have certain variations of, okay, the driver has to be in the seat, hands-on, or whatever. So those are the 6 different levels, and ultimately level 5 is where you want to be. Right now, legally, you can only test with a permit at level 1, 2. Yeah, 2. In certain jurisdictions. Major companies or technology programs happening. So major automakers, for obvious reasons, sensor makers, and Siemens. They make rail systems and things like that. They're pretty cool. Apple, honestly, when I heard a rumor that they were going to buy the car, I was like, all right, perfect. That makes absolutely great sense. They didn't, and there's a lot of chaos. So, shucks. The program, I think that the most, in fact, right now, or most likely to succeed, is Lyft. They're partnering with GM in cruise automation, which was a machine learning AI systems that was bought up by GM last year for a lot of money. So right now, I have about 50 Chevy Bolts running around in 3 cities. And earlier this month, they announced up to 180 vehicles now for those 3 cities. Today, news goes in so fast, I'm like, wow, okay, Lyft has started to, they want to roll out a shuttle service. So they call it Lyft Shuttle. And I said, oh, super, have a new competitor. So good for them. The accident rate is 0. I've seen some of the videos, and it's really impressive. Of course, one of the cars that's like, wow, it's completely independent. This is a real AI vehicle. Tesla manufacturer 2016. More sensors to help with some of the deficiencies of the earlier models, but they say it's capable of level 5. So that's pretty exciting if you're a Tesla. So here's a short clip of a Tesla S being test driven. Looks like San Francisco, but it just kind of shows what kind of machine learning on the right is happening. Individual sensors identifying cars, pedestrians, road laws, and things like that. And on the left, of course, you have a driver, hands off, making sure that people get into accidents and things like that. my opinion, this would be a narrow AI or weak AI. It's just doing that task for the driver. I think what's really impressive when I look at it from a safety standpoint is how quick the reaction time that Tesla S has over human drivers. Some of these near misses, like, wow, that's probably the correct response. 10% of the time, a human might not do that same thing. So, how did Tesla see that car swerve before the brake car had a chance? Uber. So this is a great case study in bad design. All right. That Volvo right there is Uber's automated car, and when you go back to the TIG, you can kind of see the red signals right there. So kind of, put a little close attention there. Green, 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 yellow, right? The Jeep goes in. There's another car, red, Uber car, and there's a pedestrian in the crosswalk. So that's awesome. I don't know if that was the first or second time that they, ran a red light, but after that, DMV's like, nope, you're done. I don't know if it's been reinstated or not, but they're such bad shape right now. So social norms. When you design for an AV, you have to be able to weigh different responses to how much risk other drivers have for running a yellow light or even a red light. So after that particular clip had been captured, a few weeks later in Arizona, one was making a left-hand turn. It was a yellow, but the Uber just kept going, even though it was a red and starting to turn green. So the Uber driver decided just go, instead of considering that the human driver was still in the intersection and possibly making a turn. So that was a big fail. So it's really important to look at these case studies for accidents and AVs because it gives us a way to model future behavior of those cars. And one thing we universities recognize now is you have to build rewards and incentives for those AVs. How? I don't know, but you got to do something. Laws. So like 5 years ago, it was just patchwork. It was all theoretical. Like, no, it's 20, 30 years from now. It's not going to happen. Why worry about it? But the pressure from automakers became greater and greater. And then, finally, some states started to adopt some systems and testing, things like that. Today, there's some level 5 testing going on in Arizona and Michigan. California, not yet, but we'll get there. And the challenge is you have to balance, public safety. These cars aren't going to kill someone, before they actually release, and to actually allowing these cars on the road. I mean, it's not going to be a on-off switch where human drivers and then full level 5 drivers now. It's going to be some transition. Got to handle that. Insurance. This is one of the key sticking points for a lot of governments and also the insurance industry, just because it's such a big part of the U.S. economy. It's about 3% of the workforce and about 1% GDP per year. That's big. For owners, less cost. Imagine having car insurance for like $10 a month, for gravel or something. But the challenge for insurance companies will be how do you handle the analysis for the technical failures of the car itself or the AI system? How do you analyze it? And then what kind of data do we analyze from, to make those rates? All right, part 5, potential and positive side of AI. So these are more of the future applications. I may not be aware that actually are in production or exist, but it's good stuff. Medical. I don't know that much about medical because I've been in it and I don't really care for it, but for medical, it's massive. Biomedicines, pharmaceuticals. You can find cures for diseases a lot faster, or a lot more novel than you could 5 years ago. And you have a lot more data to work with. A few months ago, Google did a demo with some guy who decided to use their mobile phone as a skin cancer detector, right, and actually perform as well or better than professionals, dermatologists. And it's really impressive. Hey, is that cancer? It's nothing to worry about. Pull out your phone. Good. All right. Farming. Of course, all of us love food and good quality, safe food, and keep the costs down. So John Deere, they pretty much have a monopoly on farming equipment in the United States, right? And there's stories of guys being able to hack their way through with tractors and modifying it. I think that's a great market if someone really wants to get into farming, making robots for that purpose. Type of robots, weed killing robots, robot pickers, robot planters, or in the areas of disease prevention, like identifying insects or what kind of disease affecting the plant. And I'm pretty sure robot pickers do exist this year. Just put it up there, just hey. Government. This is a government town, and I think there's a lot of opportunity for improving the tools of state workers, government workers, and you got to do it softly. Government workers do not like change rapidly. Right? You want to encourage it. You don't want to say, hey, no, we're not replacing the workforce, with robots or anything. No. We're just going to give you new tools to work with so that you can do more creative things, or look at problems differently, or whatever. One area of government that it's, you could spend a few talks on is law enforcement bots. Replacing private security, officers with bots, right? Or officers, robot officers that actually issue tickets or go on the street somehow, right? It's weird but interesting, One of my favorite use cases, warehouse and shipping logistics. I just like massive things being moved and things happening. This is from 2 years ago, and I know Amazon's made further advancements and things like that, but amazing. Just the amount of space that's required to move things, and the lack of worrying about worker comp injuries or anything like that. If it's a bad thing, I don't know, but for me, it's a good thing. I've been in warehouses and shipping, so I see the value in it or something. This was an open AI project. What they did was they took a human with a VR set and they had a physical board, and then a computer camera looking at it and interpreting whatever was happening in VR as well. And after one try, he was able to replicate it like that. So imagine having a system like this, but if we're actually building other things, so moving other things, just like a human would. So like in construction, how do you mortar a wall? So after one try, it's pretty accurate. So you could be remotely connected in VR somewhere around the world and go, all right, this is how you do something. And then computer system halfway around the world go, all right, got it, I'll do it. Here's some upcoming technologies that are supplemental to AI that I'm particularly excited about. Kind of like, wow, technology still has a long way to go. I don't think there's an AI winter coming yet or a collapse in Silicon Valley investing, things like that, but there's a lot of potential. There's a lot of use cases. Yeah, anyways. Blockchain. This isn't just Bitcoin, but rather blockchain. I don't know how to explain it, but it's a different way to set up contracts anonymously.
Yeah.
So let's say you're trying to sell a house, right? And you say, all right, this house is 500 ethers, $500,000 US, right? And you send it up there on the internet. Now, a buyer anywhere in the world can go, all right, let's look at this house based on what the contract says, whatever conditions it is, and they can buy that house with digital currency. Sure, you can do that with Bitcoin, but it's not as likely because it's not a contract. It's not legally binding. So, yeah. Another word for blockchain networks is darknet. There's some pretty infamous ones, and there's a lot of good about them and a lot of bad about them. I'm really excited about the idea that you could sell your excess energy to your neighbors, for digital currency pretty quickly. So you don't have to get any permits or anything like that. It's just smooth and easy. Bad. You can do really immoral things with an anonymous system like this. So no middleman in the contracts. It's cool, but it's also scary. Quantum computing. So this is something that kind of always had like a big interest in, just because I know that computation power is just stupid and amazing. It could change a lot about what we know about the internet and the digital world. Over the weekend, it was announced that the quantum entanglement experiment in China was a success. So what does that mean? Two stations, I think 1,500 kilometers apart, received the same key pair from space in like a fraction of an instant, and there's a lot of data. It's a lot different than what we have now. It's way out there. But basically what that means in AI is that the computation that can occur on a chip was exponentially greater. I don't even know what that number is, but let's say 100 times. And the picture there just shows a Z and an x-axis of 0 and 1. That's your basic 2-bit system, like 0 and 1, right? Computer processing. In a qubit system or quantum computing, it's a sphere, and that's a lot of information that can be packed in there. That's not just 0 and 1. That's X, Y, Z, and dimensions. So it's cool. Just know that the internet is not in its final state. Future AI applications I want to be involved in. One of my greater concerns to society, humanity, is climate change. It's just limiting the amount of heating that can occur globally. How do we go about that? So in the last 6 months, I've been planning a autonomous vehicle shuttle service. Thanks, Lyft. Because I believe it does two things. It reduces a lot of accidents and deaths that I've been working on with Beacon Safety Code, the computer vision stuff. And two, AV vehicles are better than gas vehicles, plain and simple, in terms of carbon consumption. Other approaches, I'm still exploring for how you can influence climate or behavior in society, and how AI can help that. But that's just theoretical. I'm still working on Cavalcade, which is a social network for cyclists and cars. And really the back end is really concerned with how AVs organize as well. So it's yeah. Anyways, Q&A. That's it. Choose your applications, yeah. So we're gonna do Twitter questions first. I'm gonna shoot on Twitter, and then I'll have Chris write down some notes.
Yeah, does anyone have any questions? Get some beer. Okay, that is an awful lot of information.
Okay. So questions for Craig. Want to type?
Do you have questions?
Yeah, you're gonna take questions from the audience, type them, and I'm gonna read them,
Okay.
and then either one of us will answer, hopefully.
Yes.
I work in insurance. I work for Meetup, and I was involved in a teleconference where they were discussing the moral decision of autonomous vehicles being faced with having to hit like an old lady in a crosswalk or the school bus and children. And it drives me nuts because I'm thinking, couldn't the car just brake and stop and not hit either of them? So to summarize, you could ask him like the moral decision of who to hit, couldn't the car just stop moving? And maybe there's something I'm missing about technology, but I hear that come up all the time. And it's kind of
Yeah. So having a deaf interpreter for one event, it's not really worth it. Second, it's a cost on the facility who's hosting it, so it's it kind of sucks.
Got it? I can start talking about this one a little bit.
Great question.
Go for it.
So in classical thinking, we'll always approach it as, all right, would you rather hit 5 people on a sidewalk or kill the driver into a brick wall, right? That's your classic setup of which moral decision the computer's going to take. And you're right, it should just break. Meaning, it should be able to make the computation before those two possibilities are the only possibilities, right? I mean, before that event happens, it should be able to slow down or stop. Like that Uber vehicle, it was way too deficient in determining, oh yeah, there's another possibility here, and that's that car coming this way, right? So it didn't have a computational model to think that through. So yeah, you're absolutely right, and that should be the top thing to look for as a regulator or tester.
I want to expand on that a little bit, because there are situations where if you're driving a car and there's a crowd of people over here, and then there's your son over here, and you have to go one way for some reason or another. You have to either swerve this way or you have to swerve that way. As a person, you're probably not going to go and run over your son. You probably your brakes are out, and you got to go one way or the other. But what's a autonomous vehicle going to do? It's going to run over the fewer number of people. And is it going to pay attention to who's currently operating the car? And that's the question for me that gets into like super weird territory. And that's
Yeah, the phone call I was on went into great detail about how the older lady, she's experienced a lot of biofilm
See?
Stop talking. This is like the CPC Society. Like chartered property casualty underwriters and insurance. It's like, what is happening?
oh boy. Okay, another question?
Yeah, another question. There have been a lot of instances in which technology is actually biased towards a specific gender or racist in some aspects, especially when it comes to AI. And I was wondering what your thoughts were on that. Like, for example, there was a computer vision experiment that was supposed to follow a face around, but could only follow white people's faces around, because they only tested it on white people. They've done like LinkedIn partial, because as AI is now, it's often not partial.
Excellent question. Yeah, that's a fantastic question. I mean, if you look at, who are the programmers, who are building these systems, and it's still, 90% white guys, young white guys at that. We're talking about 20-year-old,
Yes.
white guys, and this is something. I mean, this is a larger societal issue, but it's something that needs to be dealt with. And Craig, what do you have to say about this?
Yes. So biases, especially toward demographic biases, like race, sex, all those things. Yes, that does happen, and in my opinion, it's inappropriate and just for marketing purposes. I get it, but at the same time, it's incorrect. I believe in the basic American ideal, which is equal, every shape or form. So it does happen. I've seen it.
Yeah.
How would you go about mitigating those biases? Do you have any suggestions for what to keep in mind to not have that happen when you're coding? Because it doesn't just, like, people need to be aware of it. It doesn't just happen, right?
Yeah. Yep. I mean, personally, it's. I think there may be some sort of. I don't know if there's a technological solution to this or if it's a sociological problem. I do a lot of work with teaching kids to code, and I really, really, really encourage girls. To the exclusion of I'll be like, okay, well, you boys, you go work on this, and I'm going to focus on the girls today. Just because it's like so important that we have like that balance that is missing. But we don't have time to fix this larger societal issues, and so we do need some kind of technological solution, I think. And this is part of what really scares me about AI, is this idea that we're rushing into it at a time when we don't have our own shit figured out, at all. And we're gonna, then push all of our weird biases onto a machine that, doesn't have the kind of, safety mechanisms in its head.
I'm not sure what you said, but
Yeah.
I'll try to build off of it somehow, right? So how do you remove bias from, those biases and actual biases and weights and algorithms and data sets? I think that's a great question to ask whenever a new product comes out that looks like it could do something, right? So for example, like Amazon Echo, I don't know, the display one, right? Uses a camera. Perfect example. How do they ensure that they're not just using your classification of race or sex, to determine which products you are, unless you agree to it, right? So, I don't know.
I'd like to have a meetup on this topic.
I totally agree. Do you want a product that gives you better recommendations, and do you get an option to opt in or opt out? Right. So, it's a great question.
It's kind of a weird point, like, how much bias from your AI are you willing to accept? I mean, if you're a woman, obviously, there should be some difference and there is in like the products that Amazon recommends to you. But, if it's doing it's also taking into account some sort of stereotypes, so, based on, your hair color or something, then it's like, this, is getting into weird territory here, and this is problematic. Who would be interested in a meetup on this topic if we could find some kind of an expert on this? Yeah, me too. Okay, any other questions?
If we're interested in getting into AI, where's the
Another great question. So, I believe in the next 5 years, there's going to be a lot more new job classifications. It's kind of like, you know, how social media kind of took off as a marketing platform on its own. I think the same thing will happen for AI. A good starting point is, you know, if you're a Python programmer, you know, versus maybe a designer or somebody else. Python programmer, you want scikit-learn to do linear regression. Right? That's the most basic thing you do. Predict a simple value of like a house in a given market. Kaggle.com, TensorFlow.com, I don't know. There's tons of materials out there now that go into machine learning and kind of go through the baby steps of learning how to do it. And then for artificial intelligence, you want to narrow your focus on a particular set of problems or goals. And for me, it was computer vision, right? And I started with a simple problem, like how do I know if it's a cyclist or a car versus everything else in the world? And that sort of translated into, all right, so how do I make an app that's valuable to a user? And that's more AI than it is just machine learning, computing the image. What kind of mathematics? Algebra, if you're doing some training. If you're doing modeling, maybe basic algebra, not even that. It's so easy to run a model. Calculus helps if you're going into advanced training or advanced neural networks, right? So you can understand the weights and biases of things, and then, you know, how they kind of impact each other. Physics for me in high school was excellent, because you can kind of balance an act between the theoretical needs. Another library that I would look at in relation to TensorFlow is called Keras, Keras, and that only tackles the high-level API of TensorFlow, which means it's really easy to run basic models. So that's just another thing. So Python programming, of course. C libraries, have at it. There's a lot out there for researchers and publications, so find a lot of material. In terms of design, it's a relatively new field, and there's there's a lot of new opportunities to come. And if you can make yourself, good at something, go for it, and you enjoy it, of course.
Right there.
Suppose you wanted to design a system to catch people that are stealing from a store, like maybe a supermarket. What technologies would you need for that?
So, great question. And it's probably simpler than you think it could be. So when a person is in a store, it's not stealing yet, right? So you can have cameras set up around your shop, and kind of track where those objects are, right? So if someone says, hey, that Snicker bar is delicious, I'm gonna put it in my pocket, because I need free hands, or I'm actually gonna steal it, right? There's two options. Your camera's gonna catch it, and it's gonna recognize the object. So you need a database trained on those products, right? And it would recognize it, and then it would know where it is. And then you want
want the system to give you an alert when someone hasn't paid for that object. And you scan it, all right, it's clear. So, it's possible. It's just, what's the cost? What's the value? If it's diamonds, heck yeah, man.
Use an RFID and just step outside with it, then you know. Other questions? All right, cool. Let's see. So we're going to try to do this once a month. We want to get into more technical topics sometimes, then more sort of philosophical and ethical issues sometimes. If you have topics that you want covered in the future, let us know. You can email, you can post recommendations on the Meetup page. You can contact me at chris@minic.com. Does anyone have any kind of, that's CHRIS@MINNICK.com. Does anyone have any topics things you've been thinking about or that you want to know that we could maybe cover in a future meetup that you want to mention right now?
Robotics.
So robotics, maybe Internet of Things and where it intersects with AI. I think that'd be interesting for sure. Yes?
Just TensorFlow.
TensorFlow, just how to sort of hands-on with TensorFlow. That'd be cool. Cool. Is anyone in? Yes.
So we have like a show and tell if any of us have done AI projects. We could like show.
Great. Yes. Show and tell. Have you? Cool. Who in here is doing actual work with AI right now? So, 2 or 3? Cool. Excellent. Yeah, show and tell would be awesome. And you have to come and show your stuff then. I'll tell you later.
Everything's good, man.
All right, cool. Awesome. Couple other things before we close up. I'm trying to clean up my house, and I've got copies of my books. I always bring these because I've got extra ones, but I sell them for real cheap, and if anyone wants to buy any of my books, I sell them for $10 a piece. I've got JavaScript for Kids, Adventures in Coding, which is about Scratch, and I just wrote a novel too, and it's got a scary clown in the front. So I'm trying to sell this too, and if anyone wants to buy a copy of my novel, it'll be my new favorite person. All right, and that's it. There's still water and there's beer. Please help yourself to all of it, and thank you so much. We'll see you again hopefully in a month.
What was that?
Yes.
Matthew, but I go by Matt. So I actually just moved back a couple of weeks ago. I was doing coding. Yeah. Ever coded? Yeah. So doing Ruby and Rails and then a little bit of Angular. Yeah. It was really fun. The weather sucked, but yeah, I'm pretty sure. Like it was just. How you doing, man? Matt, Richard. Nice to meet you. Yeah, it rained. I was ready for the rain. Everyone told me it was gonna rain. Nobody warned me that it might snow. That wasn't even like a thing that got brought up. Yeah, it was like the worst winter in like 80 years apparently. This is the third of January. Yeah, this is like, it started raining starting like October 1st, and then like March it was finally done. But yeah, there was like a couple days I couldn't leave my house for like a couple days because my car was just frozen there. Yeah, it was insane. But, yeah, what do you guys do?
I'm a freelance.
Okay.
Oh yeah. That's all I do. So.
Okay. Oh, that's awesome. Okay. What got you guys into skating? You're just like,